Hello everyone, welcome to the second lecture on center of mass. So system of particles to relate center of mass holdani bolo hitan. Tunia hi solid bodies hol na rigid bodies ho iboldio. So say uniform tang rigid bodies ho hena lang pe hi uniform to non-uniform. Okay, so uniform rigid bodies and non-uniform rigid bodies ta ki hom ken jana. So in chalai video hi, so in this video we will see only uniform solid bodies. Okay, to hi center of mass part thumi boldio, so thum na pa ko non-uniform hoi boldio na. Atile uniform rigid bodies hosi tabang ha. So here I have written some of them na. For example, bodies are just symmetry o malachun. Okay, so for example, you see rectangular plate, square plate kiti hoy, center circular plate kiti hoy na, center of mass hoy layam de ha. Suppose see rectangular plate hoy layam ha. So what is the shape? Shape jo tabang hai tayam jo na rectangular plate jo. So breadth is, let's say B, so length is L, let's say. Kuti let's say center of mass hoy layam dham. So center of mass layam ngai jo na Japanese. So it will be exactly in the middle. Okay. Tabang achu if I have a square, okay, if I have a square side A to Japanese. So if I have a square side A, then where is the center of mass? Center of mass also obviously here at the center. Okay, alaita ab ngai chula na center of mass jo. Chita bang achu. So if I have a circular plate is this tina chula na. So here it will be in the middle. Okay. So for a rectangular, square, and a circular plate, the center of mass lies at the center. So now, if you have a ring, okay, so rings ang so if you have a ring, so the center of the mass of the ring will also lie at the center. Okay, yeah. So this is symmetry, complete symmetry na. So but see, two hin ring pa ko na. So half in cut leo chun. Suppose now you have a semicircular ring, okay, only a part of a ring. Kutila center of mass so alaya hin omnalay dem. It will start shifting towards this side. Okay, so here derivation is below you, so you remember the final result. Okay, final result was in the bayado. So that much. See, if I have a semicircular ring, ito mga semicircular ring, so like this. Okay, of radius r. Hichipa center of mass ham. So at a distance is that kpm h equals to 2r by pi. So from the center along its symmetry. So hichi half ring pa hai na symmetry hola ha chala hai symmetry chola na chi. So mirror image kote along this line, so at a distance of 2r by pi. Okay, so somewhere here na atila chun. So here at the distance of 2r by pi. Okay, so here you have the center of mass. Okay, atila banas biham if you have a semicircular disc. Okay, like this. So now this is solid. Okay, solid. Radius to r na atile chepa hi tang complete circular disc o malachun center of mass o laita am chula na chita ba cha chu half na cut wala chun. So the center of mass is going to shift towards alay lang achu na semicircular alay lang achu ke tol phai chu. So here where exactly is the position? So at a distance of 4r by 3 pi. Okay, so here distance of 4r by 3 pi. So here, okay, this point. So this is the center of mass. Abanachopiham hemispherical cell. Hemisphere tineso hollow hemisphere na hemispherical cell kiticho hollow tineso. So something like this. Okay, radius r. At a distance of r by 2 from the center along the symmetry. So from the center at a distance of r by 2. Okay, so here is the center of mass. But center of mass kiti a body as a light ngai lo cho. But ring a heavy center of mass does not lie on the body. Okay, a body to chi chulana chi. A hivang center of mass so it is outside the body. Okay, even this a heavy this also center of mass of body sunga na. So next you have a solid hemisphere. Solid same hemisphere. So now instead of hollow, now it is solid. Okay, so this is solid hemisphere, half sphere. Now, so at a distance of 3r by 8 from the center along the symmetry. So here, so distance of 3r by 8. Okay, so here center of mass. Abanachopiham solid cone. Solid cone too. So how does solid cone look like? So like this. Ice cream cone kona. So solid cone. So at a distance of how much? So here at a height of h by 4, from the base. Okay, from the base aju h by 4 hele chun from the apex chunga para khoja diham. So from the apex, how much is this? So this will be 3h by 4. It's a solid cone pa he kin ji kapi ko man ke dong cho. I wa kana me hello ja so I don't know, I didn't know the template, right? Okay, so don't make the same mistake. So solid cone ahi center of mass to at a height of h by 4 our maintain. So from the apex question chun witang question also from the tip zonga ti thai so jala. So they can also ask you this one na. And next one, you have a triangular plate. If you have a triangular plate, center of mass will be at the centroid. Okay, centroid. So COM at the centroid. As you triangular plate kiti po na isosceles hihan lang scalene triangle hihan lang equilateral triangle hizong le na. So the center of mass will be at the centroid. Okay, so is that naham? So it is at a height h by 3 from the base. Okay, it's whole be na. So semicircular ring, semicircular disc, hollow hemisphere, solid cone to triangular plate. You remember the center of mass. Okay, question hong kya ong kito alson direct question kitong thai cho chela he. Okay, so next you have center of mass for rigid bodies. Lecture mas hacho particles iman chula na particles. So particles iman wacho formula chupita. So xcom2 is equal to m1x1 plus m2x2 plus and so on divided by m1 plus m2 plus hitai ki bol chala na chala he atila chun he formula he rigid bodies ana che formula 9 apply ding wala chun na he chala he 8x pa he pitina ha. So what is the meaning of x1? So here x1 means the position, okay, the position of center of mass of m1. As you to hi m1 pa jong hina chumbelia ama center of mass anai chuna na body acho ama center of mass pa x component pa chuna. So that is x1 here. Okay, so similarly you will have ycom equals to m1 y1 m2 y2 tazong na si do so same formula. So ycom equals to m1 y1 plus m2 y2 plus and so on, so divided by m1 plus m2 plus and so on. Okay, kasi bangan so x1 is the x component of center of mass of m1. Okay, so x2 is the x component of center of mass of m2, right? So similarly y1 so biham the y coordinate of y component of center of mass of m1, right? Okay, so for example ka gala le na. So let's do it here. Suppose y and x. You're given two plates. Okay, so plate khatlaima two plates here. So both are mass m. Okay, so two square plates side to so it's mass m. Okay, so side is say a. Okay, and yun ki bang na identical. Okay, identical square plates. Atile so question to find the center of mass of the system. So the whole system na hotela chun chila he mass zarmam mass nium na hotela formula to m1 x1 plus m2 x2 divided by m1 plus m2 chan is yung na. So here first thing is you have to find x1 y1 x2 y2. Okay, kasi bang so x1 so biham it is the x coordinate of center of mass of m1 na hotela m1 pahi chipahi ama sa pahi 1 din ani na pahi 2 tilaw han m1 pahi ama center of mass hola ya. If it is a square plate is why say bang so center of na it lies at the center of the square. Hichi is that the coordinate so na coordinate is that ham chala here. So here you will have what is this? So this length is a by 2. Okay, so this is a by 2. So you will have a by 2 comma a by 2. Okay, like this. Kutile chepahi a khatpahi x1 hongeding khatpahi y1 na. So x1 is the x coordinate of center of mass of m1. Okay, chita banga chu ani na pa ko center of mass coordinate za ham chala here. So here, so this is how much? So this is 3 into a by 2. Na as you chi a by 2 hiza hichong a by 2 song a by 2. So 3 times of a by 2. Okay, y lang ko ki khelo na. So therefore you will have 3a by 2 comma a by 2. So now you have x2 y2. x2 y2. Kutila mass zong x1 y1 x2 y2 zong formula apply la chun. So xcom chu zat ham xcom chu m1 x1 plus m2 x2 divided by m1 plus m2. value put leo chun m1 chu m hi zana into x1 khu zat ham a by 2 plus m2 chu m x2 khu 3a by 2 so divided by m1 plus m2. So you solve this one. How much will you have? Chunga khu solve leo chun so 3 plus 4 into ma so divided by 2 into 2m. So this gets cancelled out. So finally you will have a. Okay. Chita banga chu ycom jong hol leo chun ycom chu m1 into y1 plus m2 into y2 so divided by m1 plus m2. Okay. Value put leo chun m1 chu m hi za y1 khu a by 2 plus m2 chu m y2 khu a by 2. Okay. So divided by m1 plus m2. So this is half plus half to 1 na. So I will have here ma divided by 2 into 2m. Okay. 2 to talong. Okay, so here you'll have a by 2. Okay, coordinates is ham center of mass too. So COM coordinate will be so a comma a by 2. Okay. So somewhere in the middle. Okay, exactly in the middle. Vector azong suitin zidams RCOM will be equals to so a I cap plus a by 2 z cap. Okay. Until the question got solved na. So first question, a square plate of its D and a circular disc PPKP halaya. So square plate khato circular disc khat na. So circular disc diameter to square plate by h chukibang. So they are placed touching each other. So you have a square plate, you have a circular disc. Okay. Square plate pa diameter h to hin circle pa diameter kibang na dd. So look at the center of mass of the combination. Hita here rigid body yung kipi alasun. So you put this whole thing in the xy coordinate plane. Okay, khalvaya particle ana bolta mang basuna. And then you write the center of mass of these individual rigid bodies. Atil xy plane aga koy alasun. So this like this. Okay. So this is x and this is y na. Atile sila hi square pa hi 0,0 na center of mass chu abana circle pa hi zadham. So this is how much d, 0. Right? Aji chu hi d by 2. So chi radius d by 2. So total is so this is d. Okay. Natile x1 y1 umta x2 y2 umta. So square pa hi 1 la bilang m1 la bilang circular disc pa hi m2 la leuchen. So I have x1 y1. Okay, x2 y2. Kutile xcom chu piham xcom chu m1 y1 plus m2 y2 divided by m1 plus m2 na. Mass hi kipiam na question na kipilo na. So here you take the same mass. Okay, both of them have the same mass, identical mass. So both of them let's say they have mass m tuta. Kutile chipazong mass m, this pazong mass m na. Kutile m into 0 plus m into d divided by m plus m. X coordinate of square pa chu center of mass of a square chu 0 auma. Abana x component of center of mass of this pa chu d aum na. Hotele sisa deha. So m into d divided by 2m. So mm gets cancelled out. D by 2. Okay. Abana ycom sang whole leuchen ycom chu piham. So m1 y1 plus m2 y2 by m1 plus m2. M1 chu m hiza y1 chu 0 plus m2 chu m bana y2 jong 0 na bana m1 plus m. So this is 0. Okay. Kutile mass on kiba ja center of mass hoila amdha. So here exactly here. So d by 2 comma 0. Okay. So com. So this is at d by 2 comma 0. Okay. Kutile so here also you can write like this. RCOM chu pm. So d by 2 I cap. Okay, like this. Next, two identical rods AB and CD, each of length L, are joined to form a T-shaped frame. So locate the center of mass of the rod. Example with the rod kharkanai cho. Hichi rod pa uniform hi ala na. If the rod is uniform so pitina ha mass distribution hina evenly distributed mass. Okay, the mass is evenly distributed throughout the whole rod. Okay, so if I cut it here, so this side I will have m by 2, so this side I will have m by 2, right? If I cut into 3, so I will have here m by 3, m by 3, and m by 3. Okay, as is a uniform, I na road pa cho. Hotele road khat full amal chun center of mass hoila am deham, it will be exactly at the center. Okay, so this is the center of mass of the road. Chi question hai piham road nium na identical roads AB and okay like this. Chipa hai AB tiu ta. Dang khat ba chu, so it is like this. So in the form of a T na Japan here CD. Atile what is the center of mass of the frame? Combination ba center of mass na. First thing you put in the XY plane. Okay. So this is Y and this is X. Okay. AB road pa center of mass hi position bhi hum origin am na 0, 0. Abana CD pa center of mass hola ham. So this will be L by 2. Okay. So both of them are road of length L ki pichula na chala hi. Ko tele chun CD pa center of mass hi at a distance of L by 2 ngai na. Coordinates zero chun, so this is 0, minus L by 2. As is negative y axis lang am chala na minus L. To hi AB pa hi M1 level lang, CD pa hi M2 la leo chun. Identical hi cha mass ke bang na. So MM la leo chun mass cha. So M1 equals to M, M2 also equals to M. So what is X1, Y1? So this is X1, Y1 and X2, Y2. Formula direct in apply leo chun. So XCOM cha piham. XCOM to M1 X1 plus M2 X2 by M1 plus M2. M1 to M into X1 who 0 plus M2 to M X2 who 0 divided by M plus M. So this is 0. Abana YCOM chala. So YCOM is equals to, so M into Y1 to piham or Y1 who 0 na plus M into Y2 to minus L by 2. Okay. Divide by M1 plus M2. Ang podo diham minus ml by 2 into 2m. So mm gets cancelled out. So you will have minus L by 4. Minus L by 4 so hilai so here. Okay, so this is L by 4. Okay, so center of mass is at what? 0, minus L by 4. Or so RCOM is equals to minus L by 4 Z cap. Okay. This is center of mass na. Bana question got solved there then. We have two questions. A road of 5L is bent at the right angle. Figure ke pipa hai na. Utang road khat chu nita him jo. So road pa saudan chu 5L ke pi na ji. 5L pa chu hulai ke su ko na. So it is bent into 3L and 2L. So that means I have broken down this into so 3L and this is 2L. Kasi bang so uniform road chula na. Uniform ahi ala chun. So 3:2 ratio ka su bo ala chun a mass chu pi ha. So if total mass is M, so mass of this will be so 3 into M by 5 and this will be 2 into M by 5. Okay. To chu mass song ta na. So mass of 3L tang hi chala hi road kha hi wanga chu chala hi. You have to imagine this as two different roads. Okay. So one road is this and another road is this. Kutele road mass pa chu chipa hi M1 dik to. So M1. So this is 3M by 5. Khat pa hu M2. M2 chu 2M by 5. M1 pa center of mass ko hila ham. So in the middle. Okay. So which is that the height pa hi. So total length to 3L here, half of 3L to, so 3L by 2, right? So center of mass is at 0, 3L by 2. Abana khat pa khula alai charana. So this distance is L. Total length to 2L here, alai to L. So center of mass is at so L, 0. Okay. To M1 X1 Y1 umta. Okay, X2 Y2 umta na chala hi. Formula apply lechun. So what is XCOM? XCOM is M1 into X1. So M1 is 3M by 5 into X1 who 0. Plus M2 to 2M by 5 into X2 to L. Okay. So divide by so M. So 3M by 5 plus 2M by 5 hong idi na. So total pa so M chula na. So I'll simply write here M. Okay. So you solve this. So here this is first term is 0. So 2ml divided by 5m. So mm gets cancelled out. So 2l by 5. X component of center of mass of the combination system. So YCOM to that YCOM is m1 into y1. M1 to 3m by 5 into y1 who. So 3l by 2 plus m2 chu piham m2 chu 2m by 5 into y2 chu 0 na, divided by total mass is m. So here what do you have? So 9 into ml divided by, so 5 2 are 10 into m. So mm gets cancelled out, so you will have 9l by 10. What the center of mass piham? Center of mass is at, so 2l by 5 comma 9l by 10 na. Advanced question of PKBM, take L is equals to 10 centimeter. L ko 10 centimeter na version gapul lesun sa po diha. So here 2 by 5 into 10, right? So here 9 by 10 into 10. Okay, 10 10 gets cancelled out. 5 into 2 are 10. So I will have here 4 comma 9. Okay, so this is 4 comma 9. Value ka po na L value chu. So or RCOM chu pidiha. So RCOM will be 4I cap plus 9J cap. Okay, so which option? Option A. Okay, one more question. Chipen hi NCRT solve example akam kona kan la cho ajim. Sila question piham. So you have a uniform lamina. Lamina kiti chu plate na. So here you have a square lamina. Okay, that means a square plate. Square plate thumta ma. So find the center of mass. Datang sila lamina hi combination hi 3 kg hi alachun. So each lamina is 1 kg. Okay. So first pa is 1 kg. Second pa zong 1 kg. Okay, all of these are 1 kg. Chiba na piha x1 y1 x2 y2 to x3 y3 hold on na center of mass cho. Atile c1 pa center of mass is ading ham side to kpm side to 1 meter kp na. So that means, so here this one will be at 0.5 comma 0.5. As so half a hingai chula na side here 1 here lachun. So from here to here is half. Okay, similarly along the y from here to here is 0.5. Chisa so c1 pa hi 0.5 comma 0.5 aam na. Ale abana chu c2 pa ho zat diham c2 pa ho. So here this will be 1.5 comma 0.5. As chipen hi 1 hiza, so chipen hi 0.5 na 1.5. Y lang chu again 0.5. Chita banga chu c3 ho zat diham. So you'll have 0.5 comma 1.5. Chi asaudan hi zat ham 1.5 na chi 1 hiza. So from here to here is 0.5. So 1.5 to y langa na x langa chu chipen hi. So this is 0.5. Atile center of mass ki heta na bona. So x1 y1. Okay, x2 y2 and x3 y3. So m1 m2 m3 are all the same thing. So you apply the formula XCOM to that ham. So M1 to C1 pa hai na. So 1 into C1 pa X component pa ho 0.5 plus 2 into M2 into so 1.5 X2 plus M3 into X3. So 1 into X3 ho 0.5. So divided by so 3 kg. 1 plus 1 plus 1 to 3 na. Achung ho solve lawson. So 0.5 plus 0.5 plus 1.5 is that ha. So here you'll have a 2.5 divided by 3. So you remove the decimal. So 25 by 30. So 5 are 25, 5 6 are 30. 5 by 6 na. Chito banga so YCOM chu zat ham YCOM chu. So m1 into y1. Y1 ko zat ham 0.5 plus m2 into y2. Y2 zong ko 0.5 plus m3 into y3. Y3 chu 1.5. So divided by 3. Okay, so is that the here? So again similar, same 0.5, 0.5, 1.5. So that means 2.5 divided by 3. Chipen is 25 by 30. So 5 are 25, 5 6 are 30. So center of mass is center of mass is at so 5 by 6 comma 5 by 6. Yeah. In vector, how do you write? So RCOM is equals to so 5 by 6 common I plus Z. Okay. Okay, abanahi. So next you have cavity problems. Okay. Hichi cavity problem pa hi concept pa hi na. Hichi pa hi thai ko ta. Aji chu chipen hi concept pa hi moment of inertia hol na jong na. In man diuntin aji chu. So this year in NEET exam they ask you one question on cavity problem. Okay, in moment of inertia. So first we will do for center of mass. Cavity chu pitin ha. See, suppose I have a suppose I have this student na this kharom cha. Chi this apara hi I'm going to remove part of this. Okay, so this pa hi so let's say this is a this. Okay, uniform rigid body na cho chala hi. Uniform relation center of mass hoila ham asen alaya hai na. So center of mass is at the middle. So here if I remove let's say another circle. Suppose I have removed a circular part or cavity here. Okay, this this body this is a so now you have a cavity here. Okay, so this part is removed. The circular this apa so tempat remove boleng to hin a center of mass hi alaya hin hin. So will the center of mass be still here? So now the center of mass will shift slightly towards this side, somewhere around here. Okay, so how do you solve this type of problem? See, the concept is, so here I'm going to break this into two. Okay, final result pa. So how do you get this thing? So how do you get the final rigid body? So from the initial body, okay, from the initial body, you have to remove the smaller disk. Okay, from the initial disk, this you have to remove another disk. Okay, so see, I have to assume something here. I have to take a positive mass here, and I have to take here a negative mass. Also a negative mass so I want question solve na technique pa suppose we assume that there is some a negative mass. Okay, negative mass is possible. Examples of tang mass pa original mass original disk chula. Example 10 kg here chun cavity pa minus 3 kg here chun tun chitani gom leo chun iping pot diam, what will you get? You'll get this value. So how much is this? So this is 7 kg. Okay. So concept of negative mass. Now I have to assume that there is a mass so which has a negative mass per unit length, mass density. So if I add these two, so I will get this value. Okay, right? Radius suppose this radius is r. Cavity per radius is r item. Cavity pa r by 2 so this is r by 2. Okay, so from a disk of radius r, I am going to remove a small disk of r by 2, so to create a cavity. So what will be the mass? Okay, mass of this one. Sigma sigma mass per unit area na. So mass per unit area surface mass density kiti here. So sigma is what? Sigma is, so let's say the mass of this is m1, so this is m2. Okay, so this one m1 to pm, so sigma to mass per unit area here mass to pm sigma into area here. So therefore mass m1 will be sigma into area of this. So this disk has radius r, so area to pi r square. Okay, m2 is at the so what will be m2? So m2 will be equals to minus sigma into pi is that radius pi r by 2 na Japan here. So pi r square divided by 4. Okay, right? Ibola m1 m2 iholo ha. So formula apply na ngaso m1 x1 plus m2 x2 by m1 plus m2 chula na jahem. Atila chun hito hi see this is so ibol tabang jo. So now I have two bodies. Okay, a body mass apa center of mass hoilai ham. So what is the center of mass of this? So this is at the origin 0, 0. Aba nakat pa hihulayam ham. So khat pa center of mass na, so it will be in the center here. Okay, so which is r by 2, 0. Okay, as you should see here, r by 2 na. So here you have to put the whole thing in the xy plane. Okay, put it in xy plane. Atila chun alin pa na. So this one is at the origin 0, 0, 0. Cavity pa na. Si pa hihulayam, si pa hi na r by 2, 0. So r by 2, 0. So now I have m1, m2, I have x1, y1, I have x2, y2. Okay, so apply the formula. So xcom so pidham xcom will be m1 x1 plus m2 x2 by m1 plus m2. M1 so pidham sigma into pi r square into x1 ko pidham 0 na plus m2 so pidham minus sigma into pi r square by 4. So into x2 ko ham r by 2. So divided by m1 plus m2. So sigma pi r square plus minus sigma pi r square divided by 4. Okay, that's the solve that. So you solve this, what will you have? So on all the terms, so here I will have so minus sigma pi r cube. R cube. So pi r pi r square by 4 into r by 2. So divided by anu yahu, I will take out sigma pi r square command. Okay, I will have so 1 minus 1 by 4. Okay, so if we cancel out, so sigma pi r square gets cancelled out. Nah, remaining should be ham. So here I will have minus r by 8. Okay, so r by 8 into, so 1 minus 1 by 4 3 by 4. Okay, 4 goes up. So here for 2 r 8. So this is minus r by 6. Okay. Tile final center of mass hoilang amham to minus kiti chu negative x-axis chulana. So now it is clear. So now the center of mass have shifted along this side. Okay, so somewhere here you will have minus r by 6 comma 0. Okay, so center of mass, so COM is at so minus r by 6 comma 0. Okay, apoy mo concept pa na negative mass ela pa hen hero ngai cho. So how do you get this thing? So from the initial mass you subtract this. Okay, so then you take m1 m2, okay, like this, and then you apply m1 x1 plus m2 x2 by m1 plus m2. Question kali niga solve it. Suppose here you have a question. A circular cavity of radius r by 4 is removed from a uniform circular disk of radius r. So where is the new center of mass? So I have a disk. Okay, so from a disk r by 4 is removed. So r by 4 is like this. Jala hi center jala center hilachun. So this is r. Okay, this is r. So this is r by 4. Circle niya pa na cavity cho. So this is your cavity. Ale ami thought chu piham concept chu. So how do you get this thing? So you can from the initial mass. So from the initial mass you subtract that small disk. Okay. Hichi pa hi aniya pa hi negative mass na la minus sigma, alin pa hi positive mass plus sigma. To chiten in net wala chun final pa hing poto dio. So here radius is how much? Radius is r. Aniya pa radius ko ham, radius is r by 4. Okay. Abana so m1 m2 jingay na. M1 piham chi. So what is m1 here? So sigma into area. So sigma into area to pi r square. Abana chi m2 na. M2 jizat ham. So m2 is equals to minus sigma into pi r square divided by 16. Okay, 4 square to 16 na. To chitin hi nago wala chun so chipa hing podo dio. So now you have m1 m2. So what is the center of mass? So you draw a xy plane like this. Okay. So then bigger pa alin pa hi center of mass 0, 0 amding. Aniya pa center of mass hi wala am. So it will be at where? So this is r by 2. Okay. So this is r by 4. Okay. So r by 2 plus r by 4 so that r by 2 plus r by 4. So here 4, 2. So 3r by 4 am dito. Right? So 3r by 4, comma 0. Until m1, m2, x1, x2 ki moda na. To hin formula se apply lechun. So center of mass xcom to pidiham. So m1 to sigma into pi r square into x1 to 0 plus m2 to minus sigma into pi r square divided by 16 into x2 to zadham. So 3r by 4. So divided by m1 to sigma into pi r square minus sigma into pi r square divided by 16. Okay. Solve lechun hije pa he 0 ta na chi. Pi r square. So pi r square sigma pi r square gets cancelled out. So remaining is how much? So I will have here minus 3r divided by 16 into 4 divided by 1 minus 1 by 16. So here I will have minus 3r by 4 into 15. Okay, 16 gets cancelled out. So 3, 5r, 15. So that means minus r by 20. Center of mass therefore center of mass is at minus r by 20, 0. Okay. So somewhere on the negative side. So minus r by 20, 0. Okay, finally one last question. Consider a circular disk of radius 20. So a circular hole of radius 5 centimeter is cut from this disc in such a way that the edge of the hole touches the edge of the disc. The distance of the center of mass of residue or the remaining disc from the origin will be. To ball pen na. You can directly put the answer in the final value here, okay? How do you do? Chipen R here so this is R by 4. Okay. The previous question everything is same. You just have to put the values here, okay? So here so you have something like this. You have a circular disc. It's a circular disc so a small disc is removed. Here remove radius R by 4 na. This radius R. Okay, so which means it is exactly as same as this one. Question R minus R by 20 yung pot na. So therefore, so the final answer will be minus R by 20, 0. So which is R is 20 centimeter divided by 20, 0. So which is minus 1, 0. Okay, so 1 centimeter on the left side. 1 centimeter. So the distance of center of mass of the residual from the origin. Origin it's an distance at each displacement dilo. Distance means positive value. So that means 1 centimeter. Okay. Right? Here. So I hope you understand. Next video uniform rigid bodies distribution. So mass is uniformly distributed throughout. Okay. Suppose you have a rod, okay, like this. Right? So if I cut this into half, mass mass so here M1 is not equals to M2. Okay, so this type of bodies are called non-uniform. Okay, non-uniform rigid bodies. Integration to solve so medical exam okay, I don't think they will ask you this level. Special class center of mass part 3 okay, so remember concept motion of moment of inertia concept positive mass, negative mass, and then so these things are rigid bodies, uniform rigid bodies, and remember these things. Okay, question direct question okay, I hope you understand. We'll do this much. Okay, thank you for watching.